All right, ladies and gentlemen, we're going to take a look at our exponent rules today. And so we're going to do a quick review from what we covered in Algebra 1. So if we have the same base being multiplied together, we're going to add those exponents. So we look at that as just m plus n. X to the third means 3x's. X to the fourth means 4x's. And so when we look at that, that means we have x to the seventh. If we have a power raised to a power, so a to the m, raised to the n, we're going to multiply those exponents. One way to think about this is I read this as x to the third 4 times. And so we say the word times in there, so that should tell you to multiply. But also parentheses, those are kind of our international notation for multiplication often. And so we should also know to multiply. But what this means is we have x to the third times x to the third times x to the third times x to the third. We have it 4 times. So we can go through there and count up 3, 6, 9, 12. And so there's our x to the 12. If we have a product, two factors multiplied together, raised to a power, each of those factors needs to be given the power. And so when we look at our example, 3y, all raised to the 4th power, there's parentheses there, this becomes 3 to the 4th and y to the 4th. Now notice 3 to the 4th is going to be multiplied out, so that's going to end up equaling 81y to the 4th. Anything that we can type into our calculator, we're going to. If we take a look at our next rules, we have our 0 as an exponent. So anything to the 0th power is 1. So whether it's a single factor raised to the 0th power, or whether it's a quantity of factors raised to the 0th power, it's going to equal 1. And in that same lesson in Algebra 1, we had to learn how to eliminate negative exponents. That's what we're going to do. And so what we're going to do is we're going to rewrite as a reciprocal. Reciprocal, you guys kind of know this as a flip. What that means is your numerator will move to the denominator. So if there's any negatives in the numerator, they move to the denominator. And if there's any negative exponents in the denominator, they're going to move to the numerator. So when we take a look at this, a to the negative m is in the numerator, we move it down to the denominator. In our example, x to the third is positive, so it's going to stay where it's at, but our two negatives are going to move, so it has to move down to the denominator. And notice when we move them down, that's what creates our positive exponent. So you can't erase an exponent, or so you can't erase a negative sign. You have to do something mathematical, and so you're going to take the reciprocal, and that's what moving the term or the factor does. We're now going to take a look at our division rules. So if we have two of the same base being raised to powers, then what we're going to do is subtract those exponents. So for example, we have x to the 11th divided by x to the 4th. When we subtract those, 11 minus 4 is 7. And the reason that we do that is we have these we have these 11 x's here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Being divided by these 4 x's. Well, hopefully you remember enough about your fractions that if you have the same factor in both the numerator and denominator, you can cancel them out. So if you look and see those 4 x's in your denominator are canceling out, they're subtracting, they're taking away from the numerator. And so that leaves you with 7 x's, so x to the 7th in your numerator. What we have now is kind of the same rule we had for multiplication. If we have a division, if we have a product, or I'm sorry, a quotient being raised to a power, both parts of that need to be applied the exponent. So when we look at our example, 4 over x to the 3rd power, 4 is raised to the 3rd and x is raised to the 3rd power. And so what we can see once again is 4 to the 3rd is calculated out and raised on your calculator or mental math, and we get 64 over x to the 3rd. So now what we're going to do is we're going to do some examples. I'm going to leave some on your own, so you're going to need to check those with someone that was here yesterday. We have x to the 3rd times x to the 7th. If you need to, write it out in long form. And so when we look at that, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Exactly what we get when we do 3 plus 7, so x to the 10th. We have a product being raised to a power, so everything is given the exponent. When the 5 is given the exponent, it's actually 5 squared. Remember, you have 5 2 times, so you're going to write that 5 with the power of 2. You then have x to the 6th and y to the 14th. This has to be evaluated, so your final answer is 25. Because there's only the one x base, it's going to stay x to the 6, and the same with your y. There's no other y bases, so it's going to stay y to the 14. You're going to do 3 and 4 on your own. As we take a look at number 5, we have our first look at division. We have two x's, one in the numerator, one in the denominator, so we're going to subtract, and that gives me x to the third, because 5 minus 2 is 3. We have two y's, and so we're going to subtract. 3 minus 8 is negative 5. But remember, we can't have negative exponents, so this y to the negative 5 is going to move down to your denominator. So you're going to have x to the third over y to the 5th. Now that's one way of doing the problem, and it gives you a beautiful answer. But I like to think of it this way. I'm going to look and see where do I have more x's at, because once I'm done canceling out, I'll know where my leftovers are at. So when we look at the first one, I have more x's in the numerator, and I have 3 more. When I look at my y's, I have more y's in the denominator, and I have 5 more. So that simple self-talk gets me to the same answer. It doesn't matter to me which way you do it, because both ways give you a correct answer. When we take a look at our next one, we have 5x to the third over 15x to the 7th. We take numerator times numerator for our fractions, and denominator times denominator. Those are just simple rules. It's a little bit of a large x there, but simple rules that you should remember from 5th and 6th grade. When we look at this, ladies and gentlemen, we have coefficients that need to be simplified, and then we have bases. So if we start with our x's, we can use our rule. We have more x's in the denominator, and we're going to have 4 more there. For my coefficients, I have to do what this says. I have to actually divide. So I have to do 5 divided by 15. 5 divided by 15 is 1/3, all right? So you're going to divide, and then you're going to make sure that your decimals get turned into fractions. All right? So because we just simplified our coefficients, we only have one x in our base, or in our answer. We have our final answer. When we take a look at number 7, we have a couple of rules combined here. We're going to have to take the 3 and apply it to everything that's in there. So this becomes 2 to the third, x to the third, 7 to the third, y to the third. Now when I look at my variables, I can tell my variables are done because I only have one x, and it has raised to the third power, and one y base, and it's raised to the third power. But the part that needs to be simplified are my 2 to the third and my 7 to the third. So 2 to the third is 8, and 7 to the third is 343. Now it looks similar to what we had in number 6, so you're going to have to take your 8 and your 343, and you're going to have to divide. What we find out, though, is when we divide and we take the decimal and turn it into a fraction, we find that it stays the exact same. So our final answer here is 8 over 343. It doesn't change. X to the third, y to the third. But always check your division. Number 8 is going to be one that you do on your own, and then also number 10. But before you start those, let's finish up number 9. I'm going to do 9 the same way I did number 2. I'm going to take this exponent and apply it to everything on the inside. Even though it's negative, I'm still going to use that rule. So this is 3 to the negative 2. Don't grab your calculator yet. X to the negative 4. Y to the positive 8, because a negative times a negative is a positive. Now what I'm going to do is I'm going to move my negative exponents. So these are going to move down. Y is going to stay exactly where it is. So we have y to the 8th in our numerator. We have 3 squared, and then x to the positive 4th. Remember, moving your terms, moving your factors, is what creates the positive exponents. So now when we look at this, ladies and gentlemen, I only have one y, and that's y to the 8th in the numerator. I only have one x, and that's x to the 4th in the denominator. But 3 squared needs to be simplified, and that becomes a 9. All right, ladies and gentlemen, I wish you the best of luck, and we will see you later.